The colony of New Halcyon had been built on optimism. Set on the edge of a resource-rich but politically contested system, it was meant to serve as both a trade hub and a long-term settlement. Its infrastructure was modular, its population diverse, and its leadership confident in the stability of its supply lines. Water, as always, was the foundation of everything. It flowed through a centralized purification network that drew from underground reservoirs, processed through multi-stage filtration arrays, and distributed across residential and industrial sectors. For months, the system had functioned without issue, until the contamination began. At first, it was subtle. Minor irregularities in chemical readings. Small fluctuations in clarity. Sensors flagged anomalies, but within tolerable thresholds. Maintenance teams ran diagnostics. Nothing critical was found. Then, within a single operational cycle, the system began to fail. Alarms triggered across multiple sectors simultaneously. Filtration units reported overload. Output quality dropped below safe consumption levels. Within hours, the colony's Central Water Authority issued an emergency shutdown of the distribution network. That was when panic started. Officials convened immediately. Technicians were dispatched to isolate the source. Emergency reserves were opened. Public advisories were issued instructing residents to conserve bottled supplies and await further instructions. But the data confirmed what no one wanted to hear. The contamination was not accidental. It had been introduced deliberately. Sabotage. The water supply had been compromised at a level that affected both the main reservoirs and intermediate processing stages. Trace analysis indicated a compound designed to evade standard filtration protocols while gradually destabilizing system integrity. The colony's infrastructure, though advanced, had been designed with the assumption of external stability. It had not anticipated a coordinated internal breach targeting its most essential resource. Adult engineers and specialists worked continuously to identify the extent of the contamination. Alternative purification methods were proposed. Portable units were deployed. But scaling these solutions across an entire colony population was not immediate. Time was the limiting factor. In residential sectors, uncertainty spread faster than official updates. Adults gathered in discussion groups. Some argued for rationing, others for evacuation protocols. A few proposed shutting down non-essential systems to redirect power toward emergency filtration. No consensus was reached quickly enough to restore confidence. Meanwhile, in the lower maintenance sectors of the colony, areas where housing units were built closer to service corridors and utility hubs, something else was happening. The children were not waiting. They had been raised in an environment where exposure to systems was not restricted. Many of their parents were mechanics, engineers, or survival specialists who worked hands-on with the colony's infrastructure. It was common for children to observe repairs, assist with minor tasks, and learn basic principles of systems maintenance through direct experience, rather than formal instruction. They understood pipes. They understood flow. They understood redundancy. And they understood what it meant when something stopped working. In one of the maintenance clusters, a group of older children gathered in a shared workshop space. They had been discussing the water issue not as a crisis, but as a problem to be solved. One of them had brought up a concept they had seen demonstrated during a previous infrastructure repair. Multi-stage filtration using layered materials with progressively finer separation capabilities. Another suggested repurposing inactive filtration units that had been decommissioned during a recent upgrade cycle. A third proposed integrating manual flow control to bypass compromised segments entirely. They began assembling components. Not randomly, but with intention. Scrap materials were sorted. Housings were cleaned. Tubing was reconnected. Filtration layers were constructed using a combination of reclaimed industrial filters, mineral composites, and synthesized absorbent materials used in smaller-scale purification tools. The design they developed was not officially sanctioned. It was not documented in colony engineering archives. But it was functional. They tested it on a small volume of contaminated water drawn from a localized source. The system processed the input through each stage sequentially. Sediment separation, chemical absorption, microfiltration, final stabilization. The output was collected and analyzed using a portable sensor unit borrowed from a nearby lab. The readings came back within safe consumption thresholds. The system worked. They didn't celebrate immediately. Instead, they refined it, adjusted flow rates, improved sealing between stages, reinforced structural connections to prevent leakage under sustained use. Then they scaled it. Multiple units were assembled across different maintenance sectors, each adapted to available materials and spatial constraints. The children coordinated their efforts informally, sharing adjustments and improvements as they progressed. Within a short period, localized filtration units began producing potable water independently of the central system. Word spread not through official channels but through observation. Adults began noticing that certain areas had access to clean water again. When they investigated, they found the source. Not a repaired central network, not an official deployment, but small, independently built systems operating in parallel to the colony's main infrastructure. The realization was immediate. While the central response was still in progress, a group of children had already implemented a working alternative. Engineers were called to examine the systems. At first, there was skepticism. The components were unconventional. The assembly lacked formal certification. The design had not undergone standardized testing protocols. But when evaluated, the results were undeniable. The filtration output consistently met safety requirements. The systems were stable under continuous operation. And most importantly, they were replicable. Adult engineers began integrating the children's approach into broader emergency response plans. Not as a replacement for the central network, but as a distributed supplement capable of maintaining localized water access during system-wide disruptions. The colony's leadership, initially focused on containment and restoration of the primary system, recognized the value of the decentralized solution. Deployment of additional units was authorized. Supply chains were adjusted to support rapid construction. Training protocols were updated to include modular filtration assembly techniques inspired by the designs created in the maintenance sectors. As the central water system underwent decontamination and gradual restoration, the presence of the decentralized units ensured that no sector remained without access to clean water. The crisis was eventually resolved. Saboteurs were identified through forensic analysis of system access logs and trace chemical signatures embedded in the contamination compound. Security protocols were revised. Infrastructure protections were reinforced. But among the lessons learned, one stood out in internal reviews. The colony's resilience during the emergency had not come solely from its official systems. It had also come from individuals who were not part of the formal response structure. In particular, from a group that had approached the problem without hesitation, without waiting for authorization, and without concern for hierarchy. They had simply recognized a failure and built something that worked. In the aftermath, the children's contribution was acknowledged in a public briefing, not as an anomaly, but as an example of practical adaptability under pressure. And in a colony built on engineering, survival, and cooperation, that kind of solution was not just useful. It was exactly what had kept the community functioning when it mattered most.